Based on the calculation of the maximum bending moment, and here the same type of numerical we are taking, and it is similar to the same that we have already seen in the last lecture. So here the span of the beam is given as 15 meter, bending moment is about 5 meter from the left hand support is given. Okay, so the diagram is like this. Okay, this is 15 meter is there, and the train of load is acting like number of load is W1, W2, W3, W4 and W5. These 5 loads are acting at 200 kilonewton, 300 kilonewton, 150 kilonewton, 100 kilonewton and again 100 kilonewton. The distance is 0.5 meter, 0.5 meter, 1.5 meter and 1 meter. Okay, so let us see how to solve this numerical. Okay, so first of all, again we don't know which load out of this train of load is predominant or the maximum for this particular span. Okay, so we have to calculate the maximum bending moment at 5 meter. So let us draw the span of the bridge, span of the beam for 5 meter span. So this is 5 meter is given. Okay, so this will become 10 meter. Okay, now let us call this as A, this is called as B and this is called as C. So one by one from left to right we have to move the loads of W1, W2, W3, W4 and W5. Okay, step by step, because in the numerical itself it is given that the train of load is acting on the girder of the span 15 meter from left hand side to right hand side, from left to right, and then we have to calculate the bending moment at 5 meter from the left hand side. Okay, so let us see that. For this condition, what we have to do, we have to plot the table first. Okay, so we have to check the condition. So we have draw the table here. So here we have to write the load crossing, second case load on AC, then load on CB we have to see, then average load on AC, then average load on CB, then remark. Okay, like this. So first of all, this is the loading condition is there. We have to cross this load on CB. Okay, that is we have to put this 200 kilonewton load here first. Okay, the whole geometry we have to put here like this. This is the first condition, 200 kilonewton load. So when load crossing 200 here, okay, so what loads remaining on the span AC, it will be 300, 150, 100 and 100. So these loads are acting on the load AC. So the summation of this load will be equal to 650. Okay, like this. Then here load crossing is AC is CB is 200. Now average load we have to calculate. So for average load 650 on AC. So 650 divided by span of AC is 5 meter. So that will be equal to 130. So here we have to write 130. Then 200 divided by 10, that is equal to 20. Now the condition become P of AC is greater than P of CB, like this. Similarly, now second load 300 is going to cross here. So now when the load of 300 is crossing here, okay, so which load is remaining? 150 plus 100 plus 100, that will be equal to 350 load, and on CB it will be 500. Okay, so it will be 500 here. Now average load will be equal to 350 divided by 5, that is equal to 70 here, and 500 divided by 10, that is equal to 50 here. So again here P of AC is greater than P of CB. So we have to calculate, or we have to cross the load till this condition going to change. Okay, now we have to cross this load 150 here. So 150 when we are going to cross here, so the load on AC will become 200 here, and here it will be 150 plus 300 plus 200, that will be equal to, okay, that is equal to 150 plus 300 plus 200, that is equal to 650 here. So like this. So 200 divided by 5, that will be equal to 40 here, and 640 divided by 10, that is equal to 65 here. Now the condition is changed. If you see, 65 and is greater than 40, so P of AC is less than P of CB. So this condition is final. So we have to check the condition first for this. Okay. Now what we are going to do, we have to plot the diagram. Okay. So for which maximum load the condition change, that is 150 load. So 150 load will have to kept on the apex. Okay. So now let us draw the diagram. This is the total span of 15 meter is there, like this. Okay. This is 5 meter apex, we have to calculate here like this. Okay, for 5 meter, and this is the line is there like this, and this is the maximum point from where we have to calculate the maximum bending moment. Now we have to calculate this point. So what is the formula? Let us call it as X. This is total is L. Okay, so it will be equal to L minus X. So here the formula is X into L minus X divided by L. So answer will become 5 into 15 divided by 5 into 10. L minus X is 10. 50 divided by 15, that is equal to 3.33 here. The apex will be equal to 3.33. Okay. Now similarly 150 load we have to kept here. 150 load is kept here. Okay. Then here we have to keep 300. Here we have to keep 200 load. And here we have to keep 100. And here we have to keep 100. So 100, 100. So like this we have to calculate the apex of the same. Like this, this and this. Already we have calculated for 15 meter distance. Okay. For maximum apex 3.33. Value we have calculated. So we are interested in calculating these values, apex of this value. So first of all we have to calculate the base value. Okay, so we have to calculate the base. Okay, like this. So for this the base is 5 meter, and here it is total 15 meter. Okay, now this we know that the distance from the loading, this loading we know the distance is 1 meter. This is 1.5 meter. Okay, this is 1 meter, 1.5 meter, this is 0.5 meter, and this is also 0.5 meter. Now we are interested in the base of this, for the base of this. So this is 15 meter. So 15, okay, and minus 1 plus 1.5 plus 1, 2.5. So 15 minus 2.5. So 15 minus 2.5 is 15 minus 2.5. That will be equal to 12.5. So here the distance is 12.5. Okay. Again, if we are distance is this. Okay, like this distance. So here it will be 1. Okay. So total distance is 15. So we can calculate the distance here. This is 12.5. So 12.5 plus 1, that is equal to 13.5. So it will be equal to 13.5, like this. Here also we can calculate, this is 5 meter. So this is 5 minus, this is 0.5. So 5 minus 0.5, that will be the distance of this. 5 minus 0.5, that is equal to 4.5. So here the distance is 4.5. Then 4.5 minus 0.5, that is equal to 4 meter distance. So first of all we have to calculate the base distance, and then by similarity of triangle, okay, by similarity of triangle we can calculate the vertical distance here. So by similarity of triangle we can to calculate it as 2.99 here. This is 2.66 here. Okay, this is 2.83 here, and this is 2.49 here. So these are the values we can calculate by using the similarity of triangle. Sorry. Now finally what we are going to do is we have to calculate the maximum bending moment. Now here the load is 100. So 100 into 2.66. So 100 into this is 2.66, like this, plus again here also 100 into 2.99. plus this 150 is maximum, so 150 into 3.33, okay, plus here the load is 300, so 300 into 2.83 plus this is 200, so 200 into 2.49. So when we solve this in your calculator, you will get the maximum bending moment as 240.2.5 kN meter. So this is the maximum bending moment. Okay, so this type of numerical is also asked in your examinations, okay, for 13 marks. In this case, you must remember that very carefully, that here the bending moment is asked to calculate from a particular distance, either from left hand side or right hand side. So whenever you are asked to calculate the bending moment for a particular distance, suppose 1, 2, 3, 5 particular distance or meter from left or right hand side, then in that case, first of all you have to construct a table, okay, and then in that case you have to check the conditions, okay, which load is maximum for a particular bending moment, and then only you have to plot the diagram and you have to calculate the maximum bending moment. Now the last type of numerical which is left in this topic, or you can say in this unit, is calculation of the absolute maximum bending moment. Okay, so let us see that numerical also. So the same type of numerical, we are taking, but in that case we are going to calculate the maximum absolute maximum bending moment. So you can call it as the new topic or new method. Okay, so in this case we have to calculate the absolute maximum bending moment anywhere in the section. Okay, anywhere in the section we are interested in calculating the absolute maximum bending moment. So let us take the same loading, okay, that is W1, W2, W3, W4 and W5. Okay, we know that this is 100, this is 100, this is 150, this is 300, and this is, I think, 200, like this, like 100, 100, 150, 300 and 200, like this. And here the distance is 0.5, 0.5, this is 1.5, this is like 1 meter. So first of all, we are interested in calculating the absolute maximum bending moment anywhere in the section. So what we are going to do is that here we have to calculate the CG of the load. So first of all, the first step is to calculate the CG of the load. So let us take from the left hand side. Okay, so this is 200, so it will be equal to 200 into the distance is 1 plus 1.5, 2.5 plus 1, 3.5. So 200 into 3.5 plus 300 into this distance 1 plus 1.5, 2.5 हो गया यहाँ पे, plus 150 into distance is 1, like this, plus this 100 into 0.5, like this, and then plus this 100 into 0, because we are taking the CG from the left hand side, so it will become 0. That is divided by summation of load, summation of 100 plus 100, 200, 200 plus 150, 200, 300, 350, okay, 350 plus 500, that will be equal to 850, like this. So this is the CG. So finally the CG is located at a distance of 1 point. If you solve in the calculator, it will be 1.94 meter. So now we have to relocate this CG of the point under the same loading. So it is a W1 loading is there, this is W2 is there, this is W3 is there, this is W4 is there, this is W5 is there. So 1.94 meter distance को अपने को यहाँ पे locate करना पड़ेगा. Again we have to plot the diagram. Okay, so 1.94, if you see that this is 1 meter, 0.5, 0.5, 1, and this is 1.5. The total distance is 1 plus 1.5, 2.5. So 1.94 will be located somewhere between the load of W3 and, okay, between the W3 and W2. Okay, W3 and W2, because 1.94 meter distance, CG distance, will lies between W2 and W3. So here we have to form a arbitrary load W, that is a CG load is there. Okay, now here like this, it will lies between W3 and W2, like this. So if you see the diagram from here, it will be lies in somewhere here, that is 1.94. This is 1.94. So the whole distance is 1.94. Okay, so what will be the distance between W3 and W2 and this. Let us see that. Okay, so total is 1.94. So let us see that. So here 1.94 minus, that is equal to minus 1, that is equal to 0.94. So here it will be equal to 0.94. The total distance is this 0.94, and here the distance is 1.5. So 1.5 minus 0.94, 1.5 minus 0.94 will be equal to 1.5 minus 0.94. So it will be equal to 0.56. So this will be equal to 0.56. So like this. Okay. So distance we have calculated like this, as the total distance between W3 and W2 is 1.5 meter. Like this. Now we have to calculate the CG of this and CG of this. So 0.94 divided by 2. So 0.94 divided by 2, that will be equal to 0.47. Here equal to 0.47. Here equal to 0.47. 0.56 divided by 2, that will be equal to here 0.28. So 0.28 and 0.28, 0.28. Now first of all, why we are calculating the CG distance of these two? Because initially we have to keep this W2, and then we have to calculate the absolute maximum bending moment. Then we have to keep this W3 on the particular span. Then we have to calculate the maximum bending moment. So this is the reason why I have calculated the CG of the whole load, and then we have to check, as the CG of the load is lies between the W2 and W3 loading. So initially we have to calculate the actual CG of the load, of the entire load, and then whatever the CG which is acting between that particular load, then we have to keep that load on the span, and then we have to calculate the maximum bending moment for the same condition. Okay, so let us see how to calculate the maximum bending moment. Okay, so first of all, we have calculated the CG of the load, we have located the distance, we have again calculated the distances and the CGs of the particular load. So let us call it as C1, that is called as C2. This is C1 for W2, C2 for W3 loading. Okay, so now what we are going to do is, we have to keep this W2 on the particular section. Okay, so let us see that how we have to keep. So this is the particular span is there. We know that the span of the loading is 15 meter. Okay, already we have taken the same numerical. Now we have to keep this W2 first. So we can keep this W2 loading here. Okay, so W2 is as it is. Then W3 we have to keep here. Okay, then W4 is there, and then W5 is there. So this is W5, this is W4 is there. Now this is the distance of C1. Okay, now what we are going to do is that here W1 is also there. W1 is also there. So here we know that the distances of a particular load, that is 1 meter is here, this is 1.5 meter is there, this is 0.5 meter is there, this is 0.5 meter is there, like this. Okay, now we have to calculate the maximum load under this particular W2. So for this we have to calculate the maximum bending moment. So this is there, so that point is there, this point will be there, and this one will, and again this point will be there. So we have to check what will be the distance from this to this. So this distance 15 minus, if you this is 7.5, and if you divide this C1 distance, you will get the distance from here is 7.78 here. Okay, and this is equal to 7.72 distance meter, like this. Okay, 7.78 is there, 78 plus 7.22, that will be equal to 15 meter is there, like this. Now what we are going to do is that we are going to calculate the apex point. So 7.78 into L minus is 7.22 divided by total span is 15 meter. So you will get the apex is 3.74 here. Here you will get the apex as 3.01. Here you will get the apex is 2.77. Here you will get the apex is 2.52. Again here you will get the apex is 3.23. Okay, then accordingly you can calculate the distance here, here and here. Okay, by similarity of triangle we can calculate the maximum apex point. Okay, so finally what will be the load? That is equal to 100, sorry, first of all 100 into 2.53 plus ये वाला कितना था W4 is equal to 100 into 2.77 plus 3.01 into W3 is 150 plus 3.74 is 3.7, that is 150 into, okay, here equal to W3 100 into 2.53, then 100 into 2.77, then 150 into 150, sorry, 150, 3.01 into 150, right? Okay, then 300 into 3.74 plus 3.23 into distance is 200. So if you multiply this, you will get the answer as, you will get the final answer as 2747.5 kilonewton meter. Now we have calculated the value for the maximum load of W2. Now again we have to put this W3 here, and then we have to check the condition. Now in second case we have to put the condition like, we have to put the W3 here. So this is the loading condition is there, this is W3 is there, okay, this is W4 is there, W3, W4 is there, and then this is W5 is there, W3, W4 and W5 is there. Already W3 and W2 is there like this here, W2 is there like this. Now 1, 2, 3, 4, and again here also W1 is there. So this is the condition like this, like this. Okay, so we have to calculate the maximum bending moment for the same. Okay, and then distance we have to calculate. Okay, so this is the span. Total span is 20 meter, is 15 meter is the total span. 15 meter is the total span is there. We know the distances. Okay, this is 0.5 meter, this is 0.5 meter, this is 1.5 meter, and this is 1 meter. Okay, so the distances is like this. Now here by symmetry of triangle when we calculate, so here the x distance will become 7.03 meter, and 15 minus 7.03, that will be equal to 7.97 meter will be this. Okay, now here apex will be by similarity of triangle 3.46, 3.19, 3.02 and 2.55 like this. Okay, now finally this is we have to calculate the final bending moment. So 200 into 2.55 plus 300 into 3.02 plus W3, that is 150 into the apex point we have not calculated, it is equal to 3.73 plus W4 is 100 into 3.46 plus 100 into 3.19 like this. So when we multiply this, you will get the final load is 2640.5 kilonewton per meter like this. This is also per meter. So the maximum loading or the maximum bending moment will be, absolute maximum bending moment is the first one, 2747 like this. So this type of numerical is also asked in your examination for about 13 marks. So in this case, always remember whenever this type of numerical, if you ask in the examination, you are about to solve the numerical for the absolute maximum bending moment anywhere in the section. So whenever you are asked to solve the absolute maximum bending moment in the section, you have to follow this particular step. Okay, So this was all about the unit number 2, that is influence line diagram. I will give you the PDF format notes in your Google Classroom for the unit number 2. You just go through that, okay? And if you are having any difficulty, you are free to ask anytime, okay? And you can raise your difficulties, okay? And you can ask me for the same, okay? Thank you very much for your kind attention. Thank you.